I have just a few slides, okay, just few things, and then I'm gonna go directly to the fun part where we're gonna develop a couple of agents together, okay? So just to give a roadmap, this is like what we're gonna do on the first part of this tutorial is creating an explain agent, right? What is the advantage of creating an agent in explain? So one dimension that we can see explain is as a marketplace, one of the largest marketplaces in artificial intelligence. It's where you can come, you can find models for different tasks, such as machine translation, sentiment analysis, and you can find the state-of-the-art large language models from different providers, closed source, open source ones, the ones that are open, the ones that we host. So we have this like wide options that like we serve on our platform in a standardized format through a standardized API that you can just plug in your application. Okay. The advantage here is like for all the LLMs we provide on our platform in a standardized way, you can plug them as an agent. And all the tools we have available, you can provide them as tools, all the models. Okay. So in this sense, if you go on our platform and you explore, you see like an LLM that you're interested in use, you can create an agent with that. And then all the utilities, all the models that you find, you can make them at the disposal of this LLM, such as the LLM can call it and outsource the task that the reason it should do. Okay. And the second part of the presentation, I'm gonna go explain exactly when do we need to generate a multi-agent, okay? And how like our multi-agent architecture, like when we put several agents to collaborate to solve a task, how it looks like, okay? Also based on all the theory and concepts that Yunsu gave, just go forward this to explain more or less how it works. So let's say that you have more than one agent that they collaborate together to solve a tool. Okay. On explain, a multi-agent approach looks like this. First, a user query comes, and then we do have like an internal agent. It's like our proprietary solution that it's called Mentalist. Mentalist is the one that it's gonna reason and break this user query into a plan of multiple steps. And each step of those, it's gonna assign to one of like the agents that it's available on the team. Okay. So orchestrator is kind of the supervisor, is the coordinator, is the one that it's gonna pick this plan, and it's the one that it's gonna manage the agents. It's gonna assign the tasks according to the plan, and it's gonna make sure that the agents is executing them. Once the agents finishing the steps that were intended for them to solve, their outcome is given to an inspector. Inspector is kind of like a part of orchestrator, right? It's like helps orchestrator to inspect the outcome, see if it's according to what mentalist ask it to do. And if it is, it's going to say, okay, the outcome of the agent is good enough. We are ready to write the final response. Otherwise, it's going to return to the orchestrator, telling the orchestrator the problem. Okay, it's going to inspect the outcome, tells the problem that that agent made, and it's going to provide a feedback, such as the manager, whenever it executes again, it asks the agent to execute that steps again. It's going to give this feedback to the agent, hoping that it's going to be able to do it correctly. Okay. And of course, this is customizable. As you can see, we can plug, you can work with Mentalist without inspector. You can work only with orchestrator. If you want to come up the plan yourself, you can disable Mentalist, and this one can be given by a human. So all of this I'm going to explain on my Colab. Okay. So this is the Colab. I think I provided the wrong link before, so let me make sure I share this with you.
Tiago, do you want to share, change the access to anything else, or viewer is fine for now? Oh, actually,
Yeah,
they can make a copy and on their machine, right?
yeah,
Like,
yeah. But this one is also open to everyone. So
okay.
I made it open. It's okay. So I think we are ready to start. Let me create here, open in the playground mode. Let me clear the outputs and then we can go with baby steps, understanding the simple parts, and then we can grow into like a big and nice solution. Okay. So yeah, I'm gonna present everything in Python, okay, using our software development kit. So if you have like a coding style you're gonna like, because you can do almost everything through code. The only thing that we need to go actually to our platform to do it, it's to register an API key on Explain. Okay. So first of all, I'm gonna just install our software development kit. It's the only dependency you need. So pip install Explain. And in the meantime, I'm gonna go to the platform to register an API key. So I can go to platform. And this is like my uh, my dashboard. Okay. So as I said, so we are like a very large marketplace. If you come here on the left side on Discover, you can actually explore all the models we have available for different tasks, right? Those are all the tasks we have models available. And then here we have the shortcut. Let's explore the LLMs. Those are all LLMs we have available. We do have like the entire GPT family, okay, the closed source ones. For open source models as Llama, we do have Llama provided by different vendors. So if we see here, we have Llama by Cerebras, by Grok, Deep Infra, NVIDIA, Samba Nova, Fireworks, and many others. So you can just choose the ones that you are most familiar with, or you can also do the choice by price, or the one that best works for your problem. That's it. So you can click on one of them. You can see the specifications, right? The success rate, the average latency. Here you can see the API integration, how you can plug this using Python, using Swift, or using like a Postman or Curve. Okay. And you can also try it out. 3.3. So hello, Llama. There it goes. Okay. And then all the assets, everything on our platform, all the models, all the pipelines, all the agents that you create, they come up with like an ID. This is useful for instantiating things on the SDK. Okay, as you will see. In any case, so the idea that we came here for the UI is to actually create the team API key. I can come here on the top right. I can actually see my workspaces, right? Something you can do on Explain. Let's say you were working in a project with 3 people. You can create a team, a workspace with them. You can add credits, right? Such as you have control over your credits and work there. So I'm going to choose my agent team. I see I have enough credits to start. So then I can come here. I'm going to click on Team Settings, Integrations. Here we have our team API keys. I'm going to create a new one for the sprint training. Set a time limit of 2 days. And there it goes. Created. I'm going to copy this. I'm going to save I'm going to store in a safe place. And we are ready to start. Okay. So there it goes. We go back here. Like the SDK is already installed. I'm going to register my team API key as an environment variable. And then we can start. Okay. So first thing, this is a strategy I like, right? When I do an agent, I like to first think on their tools, right? There is 2 ways you can create model tools in Explain. You can choose them by function, okay? And also like if you have a supplier that you prefer, you can specify them. Or if you have like a specific model you can use their asset ID. Okay. Here on the first one, for instance, let's say I want my agent to be able to perform speech synthesis, translation, and speech recognition. I'm going to just register a model tool specifying the function, right? Our SDK works with the idea of like factories to instantiate the assets. So here I'm instantiating the agent factory. I do have the enumerators for function and supplier, and I'm setting them. Okay. So there it goes. I have my three first tools set up. If I look into here, I can see all the functions I have available. Okay. Also, all the supplier. So let's just start with these three ones for the agent that I'm thinking about, right? And uh, just like to give you a hint, the agent I want to generate, it's on the domain of movies and series, right? I want to create an expert in movies and series. I want it to be able to actually reply in different languages. I want it to be able to also like transcribe audio if someone posed a question in an audio, and also to respond in audio if it's the case. Okay. Also to give the ability, right, of like my large language model to actually, is my speed? Okay. Yeah. If you guys have any question or interruption, yeah, feel free. Let me see. Using function only means that we may not know how many credits per media token are going to be used because we haven't specified. Yeah, that's actually a very good question. The thing is, when you specify the supplier, you can actually see the cost of, let's say, translation from Microsoft on our platform. Now, when you just specify the function, let's say you want like your agent to be able to actually do speech recognition, and you set actually the speech recognition tool. What we actually do here, it's like on the fly, we choose the most popular speech recognition tool on our platform for the case. Okay, so this is what we do internally. We're going to choose the most popular one, but yeah, like you cannot predict actually how much it will cost. So, okay,
Um,
so
yeah, Bill, you might want to just
yes,
slow down a little bit. I think the speed is a little faster for people.
okay, deal. So yeah, basically, so the agent that I want to create, it's an agent that it's gonna respond to questions related to movies and series. Okay. So I want my agent, my LLM, to be able actually uh, to respond to questions that comes in audio, right? So if I want my agent to be able to actually process audio files, I can plug speech recognition that it's going to transcribe the audio into text, such as the agent can outsource this transcription, right? I want my agent also to be able to respond in a different language if it's the case. And if I'm using an English-based agent, it should be able to outsource this task to a translation method. So that's why I choose the translation one. And if it's the case that the user also asks us like to respond in an audio, I want I want this agent should have the ability to also synthesize the response in audio. And let's say that I'm using a text-based large language model here. I need it like to equipped with like a speech synthesis tool. That's why I have one here. So in this case, we are generating three tools. Okay. And yeah, of course, my large language, what is the main constraint of large language models? They can answer questions up to the day they were trained, right? So if I use ChatGPT, for instance, their last upgrade was October 2023. If I ask of like about in my domain, if I'm talking about series and TV shows, if I'm asking about a movie that was released after this date, the large language model it's not going to be aware of. So what I need to do is also to equip my large language model with a search tool, such as like whenever it has a question and it needs to search for a new information, it can actually ask to the search tool. And the search tool that I'm using here is Tavily. Okay. Tavily is like a supplier, a partner of ours that like actually allows you to do searches in like search engines through API. Okay, so their ID is this one. So basically what I'm doing, it's actually registered a search tool as well, right? So I'm doing search tool, agent factory, create model tool, and I'm creating the tool based on the model ID of the tool I want to use in Explain. Okay. So here in terms of syntax, just to make sure, so you can create model tools based on functions, if you want a specific function, or if you know exactly the model that you want to make it available to your agent, you can actually plug the ID. Okay. So there it goes. So we do have like the 4 tools we need, let's say initially to create our agent, our movie and series agent specialist. So we can go forward and create it. Okay. So in Agent Factory, we do have a method called create. Okay. This is what you do to create your agent. Then you can give a name. You can actually specify the tools that you just registered. To show also, if you want to make this available to others on our marketplace, you need to provide a description of like what your agent is, right? Such as we just show on the dashboard. If someone like search on our marketplace for your model, and also to actually guide the LLM how it should behave, you should provide a persona, a role to your agent. It's similar to how when you call a large language model that you provide a system prompt, right? That you actually gives the instruction of how that LLM should behave. This is the same that we do here. On our agent, we're going to provide their role, their persona, the instructions, like such as like he knows how it has to behave. So here I'm saying that like you are a movies and series agent specialist. Your role is to answer user queries about movies and series in a fluent and assertive manner. Okay. And I'm also like providing here the constraints, right, for ethical reasons. So for questions that are not related to movies and series, indicate that you are not a specialist in the area and you cannot provide answers for it. Okay. So there it goes. I'm going to create my first agent. Okay, I did not actually run the Spark. So there it goes. I do have like my first draft agent, right? To run it, it's super simple.
We have a question.
Yeah.
Can we have this key only to trying and use for testing? Mm, I'm not sure I understand. Do you
Yeah,
understand
like
it?
basically this key I created for myself, right? And it's a test key. I gave like 2 days for it. But let's say once you register on our platform, you can manage the keys as you wish. For instance, you can have like a key that you just give unlimited access to it. You can actually, or just have like a test, or if you are actually, let's say you are the manager of your team, you can create a key for someone that is just testing your platform for 2 days. For instance, this is something you can do. Okay. So yeah, so and to run an agent, it's super simple. Okay, all the as similar to models on our platform. Once instantiated, you can just do agent.run. Okay, and then you're gonna have the response. Here I'm asking in which streaming service can I watch The Sopranos? So we can run it. And we can actually basically see understand the structure of the response. So there it goes. The response is done. So we're gonna see a couple of like fields that it's gonna come on the response. Okay. So one of these fields is the response status to check if the execution successfully finished. So yeah, it was successful. It returns something. There was no error. You can actually see how long it takes on the back end. So it took 8 seconds to respond. You can see how much it costs, right, in total. So this was the cost of my call. Okay. And to see the response is actually response.data.output. So you can see here. You can watch The Sopranos on HBO Max. Additionally, is available as an add-on through services like DirecTV Stream, Hulu Plus Live TV, and YouTube TV. Okay. What are the nicest part, in my opinion, for agents in comparison with LLM? It's that actually you can do the audition of the response. You can actually see the intermediate steps, the intermediate decisions that the agent took to actually provide an answer, right? And this, you can see this on Explain through the intermediate steps. So if we take a look on the intermediate steps, we see that like this agent was called, right? Our movies and series agent specialist. This was the input from the user, myself, right? This is the output that it provides. And here you can see actually the list of 2 steps. So you can see actually once it gets the user input, the LLM reasons that it has to call the search tool, the Tavili search API. The LLM actually poses a query by itself to the search tool. In this case, it says, in which streaming service can I watch The Sopranos? The Tavili returns actually the most similar documents, right? Similar to Google, right? So this is like the list of context that was returned by Tavili to the LLM. And actually, based on this context, is where the LLM reasons decided that it has the final answer to the question and actually wrote down this fluent response. You can watch The Sopranos on HBO Max. Okay. Another thing that you can see, it's let's say for managing reasons, you have like your agent, you build your agent, hopefully on our platform, it got into a production level, and now you have actually customers using, and then actually they can break down for each call the costs of like the APIs and the calls through execution stats, right? Here we can see, for instance, how many API calls our agent did. This case was like 2, right? One for the LLM, one for the tool. We can see the credits breakdown, the session. Yeah, I'm gonna go for the session ID soon, and like how much it costs in total and the runtime. Okay. So here we created our first agent. Okay. So just to recap, we first started with the tools that we think it was like useful for our agent to have. In this case, like we equipped our LLM with speech synthesis, translation, speech recognition. We equipped it with like an up-to-date search model, right? And we created our agent. So to create our agent, we gave a name, we gave the 4 tools, we gave a description to actually just show on the marketplace a summary about that agent, and we actually specified the role, the persona of our agent. Okay. There is an optional parameter that you can set here, that is the LLM ID. As I said, all the LLMs that we have available on our platform, you can use them as an agent. By default, the one that we use is GPT-4o Mini. Okay, but let's say that you want to use another one, let's say Llama 3.3, you can also do that. Okay, for that, you can just go here. Choose the LLM that you're interested on. In this case, let's say Llama 3.3. Copy the asset ID and just pause here. Okay, that's how you can actually set like a large language model for the age.
Yeah, good. There's a question. The response was in more depth. How was the response shortened to that one sentence?
Yeah, that's the summary that the agent did, right? It basically, it was like the reason that GPT-4o Mini did, right? It's just like read all the entire context, right? Found the response in that context, and actually just provide a simple sentence summarizing the answer. As we're gonna show later, we're gonna show like that actually we can control a bit more the format or the way that we wanted the response.
Um, Andrew
Yeah,
has
can
raised
we
a
prompt the
yes.
agent to provide? Yeah, we can do that. Yeah, that's something I'm gonna show. And
Yeah.
Andrew?
Yeah, say I have a preferred answer or description potentially in my own database. How would I be able to feed this into my agent?
Okay, so let's say you do have the, you mean you do have the response to the question?
Right.
think
Say,
they're referring to RAG, Tiago.
Oh, I see. You mean that you want to, let's say you want to create your own search model. Is that it?
what might be that if in the context of movies, say I am a movie advocate and I have my own curated views on it and where I believe it would be the best way to get whatever the content is. And say it wouldn't be for everything, but if it were to come up, say for Sopranos, I watch it on HBO Max and I have a preferred description. Say if this was a little bit more robust, like, can you tell me where to stream and tell me a little bit about it? How is that something that I could feed that into this reply? Because I get this is more taking it from things online, but I guess I'm thinking about connecting to like a external source, which I'd want to be used when applicable.
I got it. I got it. Yeah, that's a great question, actually. So for this particular case, you mentioned there is two ways you can do it. So on our platform, there is a way that you can create your own search mechanisms. Okay, so now I'm using the generic one as Stavili. But let's say that you want to create yourself a curated and domain-specific search model. You can do this on our platform. You just bring your documents and we actually index them to you on a model that you can actually just plug. So that model will have like an asset ID itself. And you can just like, instead of using this search tool, you can plug your model. Okay. This is something I can show how to do it. Okay. The second part, it's let's say that you do have your curated source and you provided that source through MCP or through your own web service. You can also onboard this on our platform of what we call utility tools. It's like when there is like, let's say, although our marketplace is big, is large enough, but there is a part of the puzzle we do not have available in the marketplace. You can onboard them by yourself using the utility method. I'm going to show this later how we can do this for Google Maps.
One
Great.
more question from, oh, sorry, go. Okay. Diane is asking, is the sample agent limited to answer only one query, like what you set to search for The Sopranos?
No, we can actually search for something else. Yeah, we can, as I'm going to show also following up, it can actually, you can do multiple questions in one. Okay. And maybe that's also a good hint to show the second possibility. Maybe this is related to the question, is you can actually provide follow-up questions. Whenever you call an agent for the first time and you do not provide a session ID, a conversation ID, this conversation ID is one of the outcomes of like our response. It gives you actually the session ID where it stores the entire turns between the user and the agent within that conversation. And if I call the agent again, providing the session ID, I can actually give the context, the history of the previous turns to the agent, such as like here I can do like a generic description for the Sopranos. I do not need to mention, I can just ask actually, what is this TV show about, right? And as you can see here, it will manage to understand from the history and the session ID that I'm talking about the Soprano, and it's going to provide me an answer. So the Sopranos is a crime drama television series that follows the life, right? And that's so. So, and if we look here into the intermediate steps, again, we can audit. And here we can see an interesting thing. The LLM actually did not call any of the tools that we made it available. This means that it reasons about the question I gave and the history that was given from the conversation. And it actually on their weights, right? GPT-4o Mini knows what the Soprano is about and actually reply to the user directly with their knowledge.
Awesome. One more question. Is it possible to create a GUI or graphical user interface to create the agent?
This is something we internally are working on. Nor correct me if I'm wrong, but I think Shuang it's going to present one of these graphical unit interfaces. Yeah.
We'll have a macOS agent UI builder session tomorrow, so hang tight, guys. Yeah, Noor is asking, can we control this and force the agent to use tools?
We can. Basically, what we can do is on the instructions of the persona, we can specifically mention like, please, I want you to answer in an assertive manner, but actually calling the tools. Do not use your knowledge. This is something we can do.
Great. Okay.
Or even on the query, right? What is the TV show about? Answer, we can actually say answer based on the tools.
Diane, I saw you raise your hand. Do you have anything to say? Or
Oh
you're
yeah.
okay? Okay.
With this so far with this algorithm or what we've set so far, can this handle another movie title? Say for example, not Soprano. Say for example, the user is asking for where can I find this movie Friends?
Yeah, sure. Where can I find? Let's try this though. Let me do a new question here. And we can analyze where can I find the movie? Like this?
Yes.
Oh, yeah, let's try. Let's see the response it's gonna give.
Tiago, can you comment on the speed? What is how can we optimize for speed? For example, using a smaller large language model can help here, or what our options are?
Yeah, for speed, basically, the large language model you use. Also the speed of the tools that you are using, maybe like to make the LLM to reason fast. If it's, for instance, for the example I show so far, I did not need translation. Maybe it's not something that I need. So we can also make the set of tools that we give to the agents more concise, right?
Yes.
So yeah, here's the example. So it says that I actually did not know about this movie. I love Friends, but let's audit how it gets into this answer. So if we take a look here, let's see the two steps. Yeah, so it actually asks Tavile again, and it placed this query to the search tool, where to watch Friends movie. And actually it brought that is on hbo.com. I also mentioned Netflix, and yeah, so this is like the reason it did, right? It saw my question. It actually posed a query to the search tool it has available, and based on the context, it replied to the information.
Okay.
Okay. So yeah, and then just mentioning them, we did the follow-up questions. Okay. Something else. Our agents, there is also a way that you can pose questions or provide inputs that it's other kinds of media, right? So I prepare here an audio myself. Let me see if I can actually. Please let me know if you can hear.
What is the best drama movie of all time?
Could you hear?
Yes.
Yeah. So what is the drama movie of all time, right? So I can actually bring this audio. And then when you call the agent, we do have like a method here that it's called content. That is where you can provide actually other kinds of media as images, as audios, and So here, basically, I'm gonna run my agent, right? Just asking like, please respond to the question in the audio. So here I would expect that the LLM, I'm using GPT-4o mini here, and here it does not have a ability to process audio as on the OpenAI platform. But here I would expect that it's gonna reason that it's an audio, and it's actually gonna give the audio to a speech recognition tool that we made it available for it, right? Speech recognition tool, then it's gonna transcribe. The agent, it's gonna understand what is the question about, and it's gonna answer, or it's gonna, if it does not have the answer, it's gonna look in the search, right? So here it mentions that the best drama movie of all time is often considered to be Godfather, right? So if we see here the way it did, it just calls the speech recognition, okay? It gives the audio we provided, that transcribes to what is the best drama movie of all time. And then, yeah, it does not call the search tool. Actually, GPT-4o mini here reasons and actually gave the answer itself. Okay. So another way is like, let's say that you want to provide multiple files, or you want actually your files to be part of the query you give. So instead of like this, because here what we do is like whatever the content you give, we give on the right side of the query. Another way you can do it, it's actually set a variable in the query, put in a placeholder exactly where you want that file to be. And so this is another way. So that's it. So we explore here like our first agent, right? We saw how to create model tools for it in different styles through functions and model ID, how to create our agent, how to run the agent, understand the response structure, how to do follow-up questions. So before we move to the next part, I wonder if you guys have any other question. So here it responds something else, right? So let's see the intermediate steps to.
There's a question. Could you force the agent to use? Oh, sorry. Could you force the agent to use the search tool to find out the best drama movie instead of GPT giving an answer by itself?
Yeah, we can do this on the instruction of the agent, right? Or I can do on the query itself, respond to the question in the audio. We can say, let's see, right? We can say you must search for the information. Do not respond yourself, right? It's all about like the prompt engineering you do. So let's see if it's gonna obey me. Yeah, in the meantime, if there is any other question, comment. Yeah, now, yeah, indeed. So it transcribes and then it actually posed the question to Tavili.
Tiago, I do have a question. It's probably like a hard question. I know that, but I still want to I want to understand from you what are the options. So we can use text-to-speech models and we can use speech recognition models. These are already on Explain. They support multilingual inputs. Just to clarify, text-to-speech will take any text, convert it into audio, and speech recognition will take any audio, convert it into text. If you think about it, you can use both of them in an agent to create a speaking agent where I can talk to it and then it will talk back to me. However, this will not be as smooth as, for example, ChatGPT conversation. Can you let us know, like, what's missing is to go from like this ability of audio to audio, and why it's not going to be exactly like ChatGPT in terms of smoothness.
It's just a matter now that like on our syntax, we do not have this available. We onboarded the OpenAI models, our Gemini models, but we just explore on their part, the text part, right? This is
Okay.
like the current state of the art of like our platform, but this is something that would be able to, if like, let's say I'm using Gemini or I'm using GPT-4o, and the user actually on the same format that he provides their example, their input on OpenAI, they could do the same here on our platform. And then we could use the native option of OpenAI to make it process the audio or the image or the video.
Very cool.
And also,
so
go
is that
ahead, sorry.
something that we can provide as a sample example how to do that? Is there like streaming option that we still need to enable?
If there is, yes, we still need also to enable streaming, indeed.
Okay. So just for everyone here, if you're interested in that capability, please reach out to us. It's today not immediately out of the box from Explain, but we do have the foundation for it, so we can accelerate this feature if you need that for like a business use case. But I just wanted to bring this up because it's like usually there's agent and conversational agent, like audio conversation and speech conversation, and they're rarely on the same platform. So we're definitely not supporting those natively today, but we can support them if needed for a business use case.
Yeah.
Thank you, Noor.
Indeed. Yeah.
Tiago, so Zain is asking, show us an example of a query containing two questions, and the second question relying on the result of the first one, such as finding the best comedy movie in 2008, and then ask it to find its ranking among the IMDb library.
Sure. Let's do this. Can you pose the questions for me again? Oh, it's here. Okay. The best comedy in 2008 and find its ranking among IMDb library. Let's try. And perhaps I can also explore here. Yes, I'm gonna also, this is just give you guys this hint. Something you can do here is also set the output format. Currently, we have Markdown available, so let's ask the response to be on Markdown. I'm not sure if the GPT-4o is Mini it's gonna manage to do this. Let's see.
Why do you think the Mini won't be able to manage it?
Yeah, that's one of the reasons why we use Teen agents. Just anticipating, sometimes when you use a single agent has difficulty to reason when you grow the number of tools and you actually grow the number, or like when the question you pose requires many steps to be solved. For me, what I try here for the examples I'm going to show, you're going to see like 2 is the maximum. If I start to pose a third question here, let's say, okay, find for me the best comedy in 2008. In which cinema can I watch this? And what is my direction to that cinema from the location I am? So because this requires like to call 3 different tools. And based on what I see here, like for the last one, it's going to say, okay, you can choose the directions on the navigation app. So But yeah, it managed to come up with something, but let's say if it invented, or let's do the audition here. So, no, actually, response 3. Best comedy movie 2008 IMDb ranking. So it actually chunk everything into one query, actually, and come up with an answer for. Yeah. Okay, indeed it manages to come up something, but yeah, I got the idea, and I'm gonna show how we can pose actually different questions and how it's a struggle, and I will do my argument why this is the case, that one of the reasons where we should start to thinking on a team of agents instead of a single agent.
This feels like a sneak peek, Thiago, right now.
Yeah.
So I think it would maybe help to just frame this as agents are called single step agents for a reason. They usually try to do everything they can in a single step. They're like think of them as very greedy systems that want to preserve energy. So only if needed, they will consult several tools. They will always try to do it in one step. However, team agents are more versatile and they create a plan so they could optimize a little bit more. It will mean that they will call more tools and it will be a little bit more expensive, but it boils down to the use case. You will probably, as a builder, you first will explore with the agent and the multi-agent, and based on that, decide which one is more suitable for your use case.
Indeed.
One question. Ali is asking, when creating the pipeline using the design tool, do I need to always pass the history to let the model remember, or is there any other way?
Depends on the case, right? So here for me, the next part that I'm gonna show is when I use the pipeline as a tool to my agent. In this case, I would say you don't need to provide a history for, because who is actually building the input to that pipeline is the agent. And the agent, it's going to take the history into account, and it's going to make the most likely decision on the best input to that pipeline, right? To get the answer. But now let's say instead of like using our agentic framework, you know exactly like the steps that your agent should follow, and you want to create the agent as a pipeline itself, yes, then you need to give, like, I would say, starting with 2 inputs, one for the last user utterance and another one where you're going to provide the history. Is tomorrow we're going to go into details of the pipelines, right? Or
we have some pipelines like
Some-
RAG, but we will not dig deeper into pipelines. If what we could do is, if you have questions about pipelines, which are a very, very deterministic version of agents, and they are actually mostly rule-based, so they are not the core of this training. But if you're interested in them, connect with us on Discord. We can provide you with samples. So Ali, what we can do for you is provide you with a pipeline that uses history, so you can just kind of replicate that on your own. So we can provide that. And if there's a lot of demand on pipelines, we could do like share maybe with all the audience a video recording of a demo. So you could just add it as a module. I don't think we have the capacity, Sonam, to fit that in our program, correct? Okay, so we're happy to add it as an additional module, and we'll send it via email if we see interest.
yeah, in any case, just so here, I'm going to show, because as I said, so you can plug any model as a tool to our platform. And another kind of like solution we do have are the pipelines. Basically, the pipeline is where you want to build a deterministic, you know the order of like a complex solution that requires more than one model. Okay, so I do have one here. I go here on designer. Actually, let me go on to my pipelines. So this is, for instance, a RAG pipeline. Okay, it's something that it's straightforward. They always follow the same order. So given a question, this question goes to a search, and then the search and the question are combined into a prompt. And this prompt, right? This is how the prompt looks like. So basically, this script picks the outcome of the search node, the question, and it builds this prompt here. And this prompt is then fed into an LLM that it's going to provide the answer. Okay? This is when you have something deterministic, right? The order in which the nodes should be called, it's set. It's different for our case that, like, for instance, sometimes I give an audio as an input, and then I need to run speech recognition. Or like sometimes I give text, sometimes I need to translate. So actually the order in which the nodes are called needs to be set on the fly based on the reasoning of the agent. But let's say that you do have like a workflow of your complex solution, right? Like you need to, let's say, given the data, you need to transcribe, and then you need to translate, and then you need to search, and then you need to synthesize. You can come up with a pipeline for this part, right? You don't need like actually the agent to set the order among them. And the thing is, like, if there is a part of your process that you know the order and actually you know the order in which the tools should be called, you can create a pipeline out of this, and you can actually give this pipeline as a tool to the agent. Okay. So here I just demonstrate a simple possibility, right? It's where actually what I'm doing here, let's say I want to augment my agent. My agent about movies now, he can search the internet in a generic way for movies. He can translate, he can transcribe input audios, he can synthesize if it's the case. But let's say now I want to augment this agent to also write movie scripts, right? So for this, I need an LLM as a tool, but I need to set a prompt to this LLM. So it's sort of like a complex solution. I can create it as a pipeline, and I can make this pipeline as this at the disposal of this agent. So here is the way that I'm creating the pipeline programmatically. I could of course create this entire pipeline through here, the design, okay? But here what I'm doing, it's created programmatically. So basically, I'm initializing a graph, right? A pipeline graph called movie script writer. It has one input node. This input node, I'm going to give the label movie description input because it's going to receive a short description. It's then going to get a text generation node. In this case, I'm going to use GPT, the ID of GPT-4o mini. Okay? And then I'm going to give a prompt to this LLM. I'm going to say, please write the script for a 2 minutes short movie based on the following description, right? I'm gonna mention here that I want this movie script to have around like 4,000 tokens. Okay? Then I'm gonna do the linkings. I'm gonna connect the input node to the text generation node. I'm gonna have an output node, and I'm gonna save this pipeline. Okay. If I save this pipeline, that's it. We can actually go here. Dashboard. See if it's already created. I think it's to be created. Pipelines take sometimes to be, yeah, there it goes, movie script writer. So it's just a simple pipeline, right, with one node, but where I augmented this node with a couple of information, such as like a instruction, left side instruction, and the maximum tokens I wanted to generate. Okay. Then that's it. I have the pipeline. I can run this pipeline myself, right? If I just want to do pipeline.run. But the idea here is to make this pipeline available to the agent. Whenever the agent now receives a query and it sees it needs to generate a script for a movie, it can outsource this task to this pipeline. Okay. So as we saw before, to create a model tool, we would do agent factory.create model tool. Okay. For pipeline, we can do create pipeline tool. We're going to provide an ID of the pipeline. Okay. and a description of what this pipeline does. So it's a tool to write scripts based on a short movie description. So here I'm registering my pipeline tool. And here I'm updating my agent. Okay, I don't need to recreate the agent. I can just do agent.tools. I'm gonna append my pipeline tool and I'm gonna save the new version of it. Okay. So here I have an example, right? Let's say I want to write, so here I'm gonna mention to the agent, I want to write a movie for kids about the chicken Gigi. So Gigi said to her main dream is to be a superhero, defend her siblings against the bad foxes that comes at night in the farm. However, she thinks chickens will never become a superhero. So please write a movie script that transitions DG from a sad chicken to a superhero one. So it's gonna, let's see if the LLM it's gonna generate the script itself or if it's gonna call the pipeline. Yeah, in the meantime, is there any other question?
I have one. How the hell did you think about Chicken Gigi? The name is so funny.
I was creative at that time, so
Very
it's nice
nice.
to create those documents. Yeah, so you see that it actually come up with the script. So yeah, GG the super chicken, and then there is the yeah, so and then we can take a look on the intermediate steps. Let's see what it did. And actually, if we go here on the two steps, so it call actually the movie script writer. It tries to call a couple times. There was some failure on it. But then it keeps retrying, right? Because it saw there was an error. And then it actually come up with a description that is the, yeah, GG, the super chicken, GG, yeah. So it comes with actually a summary and it manages to generate the script for. Okay. We love GG. So yeah, so now this is the thing, right? As I said, so we are, so based on the question we had before, we are a large marketplace. We provide, I think, around 80,000 models. You can combine these models on different pipelines, and all these models and pipelines, they can be made available for as tools for an agent. But there is always, we always come up with like a request, or when we work on a task or on an application, there is always a part that it's missing, right? And it's not something sometimes like, okay, I need a new computer vision model, something that it's heavy. And then of course you can come to us and we are pretty fast on respond to this request to new models or new tools, and we can onboard on our platform. But sometimes it's like for agents, it's simple utilities. It's like, okay, I need an API to check the weather, or I need something to read a file, or I need something to compute the directions calling one API. Something simple, just a small piece of code. So that's why we come up with this tool that we can actually create what we call an utility model, right? So let's say you are creating, you do sports and you use Adidas Running or Strava or something, and we do not have none of this available, but you can actually create your own utility tool that calls Strava to check like your indexes or your running records, and you can make this utility model available to an agent in Explain. Okay. Here on the case, what I'm doing, it's let's say I want to extend a bit more this agent I'm creating. It's already able to actually write a movie script. It's able to search for information about movies. But now let's say that I want them like to have information about the physical domain of a cinema, right? I want it to be able to look for cinemas, and I want it to be able actually to compute the direction, driving directions to go to a cinema to watch a movie, right? So to actually look for cinemas, we do have available Google Places. So we do have the asset ID of Google Places. So you can pose this as like a tool to your agent. So whenever the agent needs to search for a location, like a restaurant or cinema or something, it's going to be able to do it. But I do not have like a tool to compute the driving route from one step to the other. So what we did here, we come up with like the simple method, okay? This method actually uses Google Maps, right? So this is the code snippet we got from the Google Maps documentation, right? And what it does, it's like it receives two inputs, a start and end location. And what it's going to do, it's going to call Google Maps to actually compute the driving directions from the start location to the end location. And it's going to provide this as like a JSON back. Okay. You can do this to any API. Just write a small piece of Python code. Okay. What you need to do is like a piece of Python code function. Sometimes we do not have the dependency for the API, so you can actually add this small piece of code here to try to import Google Maps. If there is no Google Maps, you can install on the fly. Okay. And the most important part, test your code, see if it's working, if it's fine. If it is, don't forget to provide a doc string with the description of your tool. Because it's based on this description that the agent it's going to reason, right? Let's say I ask for a driving direction, and then the agent actually when we provide the instruction to the agent, we provide the tools that they have available and the description to those tools. So you need to give like a good description, such as the agent understand of what that tool does. So here we are just like mentioned, get transport directions from start to end location. Okay. So I'm gonna paste here my Google Maps API key. So let me pick it.
One trick for people who do not like to code from scratch, like myself, you can always go to one of our large language models and ask it for a code.
Yeah, indeed. Yeah, go to the playground and yeah. That works very well actually. Like it's
Yeah. I use Sonnet 3.5 and 3.7. Both of them are on the platform, and my experience is that they provide the most like polished code snippets. So I just say in a Python format, I want a tool that allows me to send emails, and that I just copy this code into a utility, and it becomes my utility. A few modifications sometimes are needed, like sometimes it might request that you register in some kind of service. Usually, it's mostly a password and a username that are missing in that code snippet. But yeah, use AI to build AI.
yeah, and I'm very curious because also like all this documentation that we are generating, we are sharing, spreading on the internet. And most part of those AIs, they are trained on these documents. So I'm very looking forward to the moment of, let's say, Claude 4.0 or 4.1, where actually they were trained on this code and they're going to actually manage to answer questions based on the Explain framework, such as we can go, okay, how can I run a model in the Explain framework? And they're going to actually come up with those code snippets. So that would be very, very nice. But yeah, so here it is. So you do have your piece of Python code, right? That you generated, or you go on the code snippets on the provider you're interested, or you actually ask for the LLM. Oh, Diane. Yeah. So I can go here. So let's try this. So basically, Diane is asking to demo how to ask for a code snippet, right? So let me choose an LLM here. Let's use GPT for all means. So please give me a code snippet on how to start a GitHub repo. Let's see. I forgot to ask in Python actually. Yeah, it come up with something. So it broke down here because I think we can actually do this programmatically. So here, so I'm just diverging a bit, but we can actually do to instantiate just a model on our platform. You can do explain factories, import model factory. So we do have agent factory here. We have model factory, right? So I'm gonna get the model.
So these
And
two lines of code, only these are so super powerful. You can connect with all large language models using these two lines. You just change the ID inside of the Git, and you can switch between talking to OpenAI or Claude and all without having you go and register and create like an account on their systems. You create one account with Explain, and then you access all of them together and only pay as you go as well, which means that currently, to get an API from OpenAI or many of the providers, they request you to pay at least $20. You don't have to do that. You just pay for what you use on Explain. But I think it's worth Thiago mentioning why the code was snipped in the interface in Studio, because we are limiting the number of tokens to be generated there, and mention how you control that here.
Yeah. So here, so basically we control to 200 tokens, something like that, because it's just like a tryout feature, right? But here, when you call programmatically, right, you do have a model and it's an LLM. You can actually manipulate the max tokens. I can actually set the temperature.
And that
you have
allows you
access
to control like the expense, correct? Because every token is what you pay for. So if you know that it shouldn't be more than like 500, you would limit it this way.
Yeah. So then what you would have to do is to copy that part and just test it out, actually replacing for the constants. But this is a way, for instance, that you could come up with like a code snippet to store a GitHub repos. You could wrap it up this into a function, and you could, as we did here for Google Maps, right? And you could actually, to onboard that functionality on our platform as a model itself, you just need to do model factory dot create utility model. And then you give a name, you give the code itself, and then you do have your utility model. Okay. So here we created ours. Also, you will be able to see it on the dashboard, right? Because the utility model has an ID itself. And here, what we're gonna do is like just remind, we want our agent to be augmented with Google Places and this Google utility tool to compute mapping directions. So I'm gonna create the model tool for my utility model. And then I'm gonna do the Google Places, which the ID is this one. And then I'm gonna just, on our agent, I'm gonna just extend the tools, right? And then if we see now, our agent has 7 tools, right? And then here it's like, yeah, so before I was in the city, Joinville, on the south of the country, right? And then let's say now I'm interested on what are the cinemas near Joinville and how can I get in one of them from Art Museum of Joinville, right? So let's see. So here I'm posing 2 questions. Let's see if it's going to be able to reason and call the right tools. So there is a question here. If we there is a SAS question. Oh, I missed.
No, that's more like pricing, but that's okay. I think Noor and I can take care of that question. But there is one question. If we implement the pipeline Does that imply it will provide us with strategies to address recurring support cases? Additionally, does this suggest that the pipeline will function as the first line of support?
I'm not sure if I get the question. Let me see. If we implement the pipeline, does that imply it will provide us with strategies? Oh, cannot implement, but does that imply it will provide us with strategies to address recurring?
Could it be that, like, do you want to prefer the pipeline as the first tool to use for the agent to use? Is that the question? Uthman, if you would like to follow up.
Yes, as well. That's what they mean.
Yes.
Yeah.
Can we prefer tools? Like, can we say always use a pipeline first, and only if it doesn't match, try the other tools?
Could we add that like an instruction of the agent?
Yeah, you can write kind of like in natural language, create an instruction. Let me perhaps show you guys an example. Just diverging here a bit, but CRL. So this is an agent that we create to respond to financial questions. Okay. So, and if we see here, the agent has 4 tools. Okay. And the way that we do the instructions was like this. We said you are an expert in finance and can answer questions about financial statements. Given a question, take the following steps to answer it. And then we give here a list of 5 steps. So we said extract, mention financial formulas in the question and search for their explanation in one tool. Skip this step if no formulas are mentioned. Extract mention terms and search for them on the XBRL terminology tool. Extract mention facts and questions in the financial fact index. And then we mentioned to do not skip this step. And then we actually come up even with a condition. You say, if no math is involved, respond the question with the most relevant information found. If math is involved, use the Python interpreter to calculate the answer. Respond the question in a friendly and concise manner. And then we mention here, always perform the steps in the order they are presented before responding. So actually on the instructions, you can control if you, let's say, call a tool after the other, and you can actually give the order. But also if you do have like completely the order, it's such as deterministic, it's better to create a pipeline. Instead of like an agent like this, you can just create the pipelines with the nodes in the order that they should be executed. Okay, so there it goes, right? So returning here, like our agent has 7 tools. We added the new tools to actually look for places and to compute driving directions. And then we paste here like a 2 questions query to test this, right? So what are cinemas near Joinville? And how can I get in one of them from the Art Museum of Joinville? So if you see here are some cinemas near Joinville, it come up with a list, right? And let's say if it manages to come, and then, yeah, so to get to GNC Cinema Shopping Garden from the Art Museum of Joinville, follow these instructions. So, and then here it gives the driving directions. Okay. And then if we audit that response, we can see here that it actually first calls the Google Places and looks for cinemas near Joinville. Google Places return this complete response that it's not very readable, right? Although the agent can do it. And then like we call the utility to actually, it gives the start location as the Art Museum of Joinville and the end location as GNC Cinema. And then it manages to come up with the instructions. And based on this context, the agent manages to respond to 2 questions. Okay. Okay. So everything we did so far, it's at that moment that you're gonna just test. right? So you're going to create an agent, you're going to add a tool, you're going to give some test cases, see if the response is good enough. It's not, you're going to check the intermediate steps, you're going to debug. This is part of like the development process. The thing is, like when you create an agent through agentfactory.create, it lasts on our platform for 24 hours because it's a draft. We are counting that you're just developing itself. But let's say that you come up to a point, let's say this point is good enough. It's responding to the questions, your test cases as you expected. And you want to actually have this on your dashboard and you want to start to share with people, right? What you can do is to just deploy your agent. Okay, for this, you just do agent.deploy. Once you do this, your agent it's going to be permanently available on your dashboard, and then you can share their ID with others. You can plug them on your Python applications, on your other application, and then it's going to always be ready to be executed. Explain handles all the infrastructure, the deployment part for you. You just need to do this, right? With one line of code, you deploy, and it's ready for you to use. Your solution as it receives calls, it's going to be we scale automatically, right? So as I said, we handle all the infrastructure. And also, like, you don't need to create the agent every time. So whenever the agent is created, it does have an ID, right? You just need to do agentfactory.get. So it's simple as this. With 3 lines of code, you can instantiate and run an agent that it's already created and deployed, right? So in your Python application, once you start, you can instantiate your agent. Whenever there is a new question, you just run it, such as like how many Oscars Angelina Jolie have, right? And let's say you're good enough, right? You don't want to use the agent anymore, you can just delete it. Okay. So I hope I managed to go deeply with you on how to build agents and how to call our models, how to call our pipelines, and how to actually develop an agent in our platform. I wonder if you guys have any comments, questions, because then I want to jump to the part of the teams when actually we're gonna grow our solution to have different agents collaborating with each other to answer the user queries. So
Could you quickly show or how the agent's ID is in Studio now?
I actually just deleted. Sorry,
No
but
worries.
yeah,
The next one.
let me create it again.
Let's just call
Let
create
me.
deploy and show that just this part.
Okay, let's do this. So let's demo through. So that's it,
Very long
agent,
name.
right? And then if I do agent.deploy, the agent is created. So now if I go here to my dashboard, here I have all my agents, and I'm here because yeah, I already created before as a draft, right? So now I have the deployed version. And of course, you see the specs here, how to integrate, and then you can also try it out through here.
And on the top is the ID, correct? This is the one that you will refer to in order to call this agent from anywhere.
Exactly, yes.
Beautiful. Okay, let's jump to team agents because this is an important topic and we have so little time.
Okay, let's go there. So let me start with failures. So I just showed the perfect world now. Let's now show that it's not so simple, like to develop. Our platform is simple, but to develop the agent and make it run, sometimes it can get complicated and you need to try a couple examples. So I'm going to create the agent we had before, right? This is the agent. It has like 7 tools, right? Speech synthesis, ASR, translation, search tool, pipeline, Google Places, and Google Maps. What is the limitations of agents? They start to struggle when they have to reason among multiple tools, or they need to solve queries that actually require multiple steps to be solved. Let's show the second case, right? So let's now extend the number of questions I have. So I'm going to say, what are the cinemas near Joinville? How can I get in one of them from Art Museum of Joinville? And what can I watch there tonight? So let's try. So yeah, it manages to find the cinemas. Okay. So it brought the cinemas. But then to get to one of the cinemas from Art Museum of Joinville, you can use a navigation app. As for what tonight to watch tonight, please check the cinema's website or call them for the latest showtime. So as you grow the number of steps that it needs to reason, right, the number of questions, it gets lazy, right? It's not gonna do it. So if we see the intermediate steps, especially if you use a small LLM, that it's what we are trying to do here, like use a cheap LLM. So if we see on the intermediate steps, it actually looks for Google Places. But that's it. So if we see if there is a second call, it's not. You just call Google Places, and for the others, it provides a generic answer. This is not what we expected for, right? So it's up to that point, right? Whenever you get into this stage that you have like many tools in a single agent, you may need to break them down in more than one agent and make different experts. Or when it's the case that you see that you have like a query that is too long or that it requires to be break into several steps to be answered, these are the cases that you actually gonna need a team, okay? And here's where we're gonna create our team. Here's just a simple team. We're gonna use the same agent, but we're gonna do something. We're gonna wrap this agent into our team approach, and we're gonna turn it on mentalist, right? So if we remember here, so one of like the internal agents we do have is mentalist, and what mentalist does, it picks the user query and it breaks the user query beforehand into several sub-steps that needs to be followed in order to get into the point that it's gonna answer the question. And it's also assigned to the agents, but since we just have one agent here, mentalist is always gonna assign all the steps into the same agent. Okay. So let's run it now. So I'm gonna, to create an agent, I'm gonna instantiate the team factory. I'm gonna create, I'm gonna set the agents. I'm gonna enable mentalist and I'm gonna disable inspect. Let's try. Let's see. So now it came a better, like a more formatted answer. But if we see, here's the information you request. In Joinville, you can find several cinemas. It mentioned the cinemas. Getting to a cinema from the Art Museum of Joinville. Still generic. To reach any of the cinemas from the Art Museum of Joinville, you can take a taxi or use a ride-sharing service for convenience. This is not what we expected, right? Movies shows tonight. For the latest movie lists, I recommend checking the official websites. This is not what we asked for, right? But then we can actually take a look into the intermediate steps, and we're gonna see something that happens. When you develop an agent, you will see this happening. As I said, we are using a cheap large language model here, right? GPT-4o. And this is the first step, is that where it actually calls mentalist. And here we can see the list of steps it actually predicted. So it says, search for cinemas near Joinville, then get transport directions from Art Museum of Joinville to the nearest cinema, and then provide movie options available to watch tonight. Okay, that's a great plan. But what is the main problem here? If you see for the second step, it assigns the second step to Google Maps instructions. But if you see here, we just have one agent. And the name of our agent is actually Movie and Series Agent Specialist. We do not have an agent called Google Maps Instructions. So this means here that GPT-4o Mini, it actually hallucinated the information, right? So just to show the kind of problems that we bumped into when we develop an agent. So what I can do here is I can set GPT-4o. That is like a more expensive, but a better model, right? So I'm gonna go on the platform. Remember, I'm gonna pick GPT-4o. And I'm gonna plug here the LLM ID for it. So here I'm creating the team. And then let's run it again. Is choosing a more powerful model the only option? No. Yeah, there is like two, at least the way I see more two options possible that I'm gonna show to you to keep like our model cheap, right? I'm just trying to, let's say, the brute force one here. Whenever there is a problem, the one that you less needs to think is actually you go there and you plug a stronger LLM. But yeah, there is a way to do smarter and cheap. So yeah, so here we see that it manages to do sort of, right? So it finds the cinema near Joinville now. It got the direction from GNEC from the art museum, and actually it kinds of gets the movie playing tonight at GNC cinemas as part, and then it mentioned as part of the 6th edition of the Cinema Week, a variety of movies are available, including comedies, adventures, fantasies. Tickets are priced at 10 for all films, and there are new releases available this weekend. It did not provide like the list of movies, but then like we go back to the question that Andrew did at the beginning. I would not say that this is a problem on the agent itself, but on the generic search tool I'm using, right? I'm using Tavily. I ask for the movies in a specific cinema in the south of the country. It did not, maybe on the context, I did not have the information of the movies. This is the case, for instance, that we can create a curated source, right? Or using a more domain specific search tool for this. But indeed, if we see now, it manages to fill it up the steps, right? So if we see the plan that GPT-4o come up with, it actually search for cinemas near Joinville using the Google Places API. It mentions the right worker, right? And then select one of the cinemas found in the previous step, and then get transport directions from the Art Museum of Joinville to the selected cinema using Google Maps instructions. And then search for movies playing tonight at the selected cinema using the Tavily search API. So it got like a very good plan, right? It even mentioned the tools. And this is the thought that the mentalist has, right? So the user is asking for cinemas near Joinville, directions from the Art Museum of Joinville to one of the cinemas, and information on what movies can be watched tonight. The movies and series agent specialists can handle the cinema and movie related queries, while the directions require the use of Google Maps instructions. So it manages to come up with a plan, and it manages to answer the question. However, let's say this is the, as I said, right, as Rangan posed here, we need to keep the agent cheap, right? If we need to go on production level, we want to use like a small LLM or a cheapest option. So what we can do actually is to break down our agent into more than one expert, more than one specialist, right? So here, what did I do? I come up with like a better team architecture, still using GPT-4o Mini, but the first one, it's going to be a movie expert. This is an agent. It's going to have the initial tools we set for this. This is going to be the movies and series agent specialist, is the one that it's like responsible to answer the queries about movies and series. Okay. the movie expert. The second one, it's gonna be the cinema finder. It's the one that actually, the role is to answer queries about cinemas and what to watch on them in a fluent and assertive manner. And this one, it's gonna use also a search tool, but it's the one that is gonna have Google Maps and Google Places tools. Okay. So now if I try to create my team, enable Mentalist, and now I break the tools and break their expertises in 2 agents. I'm going to provide these 2 agents. We're going to see that GPT-4o Mini, it's going to perform better than the first try. Let's see the answer. Any question, any comment in the meantime? Why should the inspector be disabled? Yeah, I just did not want it to try for now, but I'm gonna show that we can also enable that. Yeah, so there it goes. So it finds the cinemas near, it got the direction, and it actually got the list of movies to watch, right? So breaking the aid, like let's say we have an agent that we expect that single agent to do so many things, but we are using a smaller LLM, it's not going to be possible. Then maybe this is the case where you need to break down your agents into multiple experts and you need to create a team. Okay. Also, for now, we are trusting in Mentalist, an LLM, to actually come up with the plan. But let's say for some reason there is a case that you have the plan. You know how those experts, you want to be the manager, right? You know how those experts, they should behave and the tasks that they should be assigned for the queries that the user is going to give to that team. In this case, we do have the concept of tasks, right? You can come up with tasks and you can assign the tasks for each one of the agents. So here's what I did here. Instead of rely on Mentalist, I'm going to be the Mentalist as the developer. I'm going to come up with the tasks. So one of the tasks is cinema search. This means that it needs to search for cinemas near the area specified by the user. And the outcome is a list of cinemas near the specified area. Okay. Task 2 is movie search. Search for movies near the area specified by the user, and it's going to return this as a list. And the third one is the find directions, right, between the cinema address and the user address. Also here, if you want to give them a pipeline style, you can also come up with the dependencies, right? You can set dependencies among them. We're not going to set them here. So those are my agents. What I'm going to do on agent tasks, I'm going to add those in the single agent I have. I'm going to add these tasks. I'm going to create my team, right? In this case, I can make Mentalist and inspector disable because I come up with the tasks, actually the plan that should be followed by those experts given a query, and I can actually ask for, right? And whereas there is the response here, yeah, just answer the question of Zhao. One of the nicest features we do have, we are still evolving this feature, but on Teams, something you can do is to set the inspector. Inspector is the one that actually gonna, given a response of the agent, it's gonna inspect to see if it's correct. So far, an inspector in our case is just an LLM as a judge. Okay, so it's just an LLM that it's gonna receive actually the task given by Mentalist, the input to the agent, and the outcome of the agent, and it's gonna evaluate. If it's correct, it's gonna give the signal to orchestrator that it's correct. If it's not correct, it's going to give a feedback to the orchestrator. As Yunsu mentioned before, something that we are come up with as well is guardrails. So it's the idea that you're going to be able to set multiple inspectors on our platform, right? Using those guardrails. So let's say that after each agent outcome, you want to check if there is offensive language, or if the sentiment analysis is bad and it should be positive, or if there is profanity. All of this, you're gonna be able to equip your inspector with all of this in the future, right? But for now, is an LLM as a judge, right? It's as good as it is. So to do this, you can set your team, right? And just enable the use of inspector. Okay. And just to show here before, so this is the outcome for when we specify the tasks, right? It manages to come up with the list of cinemas from Google Places. It comes with the directions with the Google Maps. But in these cases, it did not manage to come up with like showtimes or movies current come on Joinville. But I believe one of the reasons for this is what we discussed before. It's that we are using a generic search that's not so domain specific for cinemas, right? So yeah, with this, I finalize my presentation, and I'm here to answer for questions, doubts. If you guys would like me to try something else, yeah, I'm around.
Thank you, Tiago. There's a question. Can we add a pricing agent to also optimize price for the task to execute?
That's a very nice idea, actually. We do not have this, but yeah, thanks for the suggestion. This is actually very good to forecast the prices and see what can be used. Yeah. I know that like some cloud providers, they do have, right? Say if you're using the cloud, they do a forecast of your prices, and maybe we could do this like through an agent, or how to optimize using the cheapest option. Yeah, that's interesting.
Very nice. Any other questions, guys? We do have a 10 to 15 minutes break coming up before the next session, where we will learn from Asma about more hands-on, like not hands-on, but more practical use cases where she's going to show you how the agents are built. But before we go on a break, if you have any comments or questions for Tiago, now is your time. We have a question. How does the
Yeah, the
response
inspector.
compare with or without the inspector?
For this case, I'm not sure if it's a good one, but this is let's see how the inspector. Yeah, because for the example we gave, basically, if we see here, the inspector did not approve. So it said the response is fundamentally incorrect, as it fails to provide the requested comprehensive list of movies, showtimes, and relevant details for cinemas near Joinville. Instead, it suggests alternative sources without fulfilling the task requirements. So I think inspector did not approve the answer, mostly for this example here, that it could not be predicted. Let's see yeah. So how can I so for the first one of the plan, it mentions as correct that it's to get the list of cinemas. Yeah, so it basically it tries multiple times until it fails, right? But the idea is it could not fulfill when we ask to search for movies currently showing in the cinemas local near Joinville, it did not manage to come up with a good answer, and the inspector mentioned this, and it keeps retrying multiple times.
So the inspector, would you say the inspector is being strict, or how can I make it less strict? Like, can I, in my instructions, make it a little bit more lenient?
In this case, I think that actually the inspector is correct, right? Because if we see on the other examples where we do not use inspector, you see the outcome for the movie options were not good enough. only this one, only one of them that we tried that actually come up with an information that there is a discount on the GNC cinema. But even like this, the response was not good enough. Yeah, you see, he mentioned here as part of the 6th edition of the Cinema Week, a variety of movies are available. What actually are those movies, right? It did not came up with this answer. And I think the inspector is correctly pointing on this.
Got it. But just to understand, like in terms of flexibility, if I go to my instructions and make them like less strict, or do you have instructions here, or are you just using the query?
I see. No, definitely. So if we change or on the query, right? Here, like, what can I watch tonight, right? But if I make this like a strict,
No,
or is there any
so
discount on the cinema or
yeah,
something like that?
but I'm not thinking of the user query because we can't control the user query. What we can control are the instructions we give to the agents. But in this example, it seems that it's like you are a cinema finder, so that's your instruction, and that's the only place where we can maybe reduce the strictness.
Yeah,
Because
yeah. If I would tackle this problem,
yeah,
I would say, yeah, I could maybe make the instructions more flexible. But I think before I would train a new search tool exactly with the list of movies or like using an API. I'm not sure if there is an API for this, right? But an API that actually given a cinema place, it would find like the what is showing time there.
okay, that's a good insight. So so how you control the agent is limited to really natural interaction, because an agent is run by a large language model, and large language models only have a few parameters that you can control, like the temperature or the max tokens, and they're not really telling a lot the agent what the LLM what to do. Only the instructions that really do influence the behavior. And how inspector works, and correct me, Thiago, inspector takes the user query, so my question as a user, plus the developer instructions that Thiago wrote into the agent, plus the output, and matches if they make sense together. If the instructions are very strict, the inspector is more strict. Is that correct? And this is where it leaves you the developer with two options: making the instructions a little bit more flexible, that's one, or using better tools. And we have observed how users are using Explain, even other platforms that have agentic. It's usually they're combining Tably or Google search with scraping, website scraping, assuming that will provide them all the information needed. And theoretically, it will, right? If you have a scraper, it will provide you all the information in IMDb, for example, if they don't restrict scraping. But the issue is these are sometimes the context becomes so big and the agent will not capture all the details, or they will mix and match important information with non-important information, because really what they're scraping is like almost like copy blindly. If you're using an API for the website, if it's available, then you're actually getting clean data. And I think in that example, IMDb does have an API that allows you to really send clean instructions, like in that time frame, what are the best movies rated above 10, etc. So you could actually get a clean list instead of like a lot of text, and then the agent has to clean that.
Yeah, for sure. Yeah, just to complement what you said, also within the context of a team, you can also provide instructions on the tasks you set to the agents as well. Maybe this is also where you can like add your constraints, add your inputs, and see exactly the tasks if there is multiple ones that you want an agent to perform. Yeah, Andrew?
Andrew, yeah.
Yeah, I had a question along those lines. So IMDb, let's say, has an API. So is it something where using an agent, it could be able to parse through that? Or is it something where if we found like let's say they use Swagger API where it has all of the instructions, is that something where it could be used to manipulate the API, or would it require us to be looking through the documentation itself and then determining the paths for the API to go through?
Yeah, so basically Google, let's say IMDb API, you can onboard on our platform as an utility model, but yeah, then you need to write it down a code snippet for it to access.
I
And
think
I
the
would say
question,
the code.
Thiago, how much do we need? Like, do we need to educate the agent about how to use IMDP API, or is it enough just to provide instructions, like this comment, get transport directions from start location to end location?
I mean, if you already wrote the code, that's it, right? The code, it's gonna do whatever you ask for, and then you provide a good description for. Now the other part is if we want the agent to generate the code itself. This is something that it's possible, but it can make a mistake. If
Yeah, so
because
sorry, to answer Andrew, as Thiago mentioned, the only thing that the agent reads from the utility is its description and the parameters that are used. So, for example, if that utility main is used as an agent tool, it will read get transport directions from a start location to end location, and that utility takes input start location and end location. That's all the information. And based on that, it's going to reason how to use the tool. So you don't have to reason about it. You only need a description of the tool and it will figure out everything else. Yeah. And let's say, for example, GitHub. GitHub, there's like, if you're using GitHub, there's so many, it has an API and there's so many things that you can do with GitHub. You cannot describe all of these to the agent. What you do is just provide a simple instruction. Like this is a utility that allows you to search for repository based on name. That's all what the agent needs, and understanding that the input is going to be named, for example, name of the developer or the owner of the repository. If you are using a large language model to create a utility, you only need to also ask it to add this description at the top of the utility. This way you guarantee that the agent has enough meat to understand how to use the utility. That's all.